All right, today we're diving into a technology that could completely rewrite the rules for electric cars. We're talking about a potential solution for pretty much all of their biggest problems. Imagine EVs with unbelievable range, charging times that are insanely fast, and absolutely zero fire risk. Welcome to the world of solid-state batteries.
Okay, so let's just kick things off with this question. Just picture it for a second. What if range anxiety was just gone? A thing of the past. Imagine getting into an electric car that could go over 900 miles on a single charge. And then, when you finally need to plug in, it's done in the time it takes you to grab a cup of coffee. I know it sounds like science fiction, but that's the very real future that solid-state batteries are promising us.
So to really get why solid-state is such a seismic shift, we first have to talk about what's holding us back right now. The battery that's in basically every EV on the road today, the lithium-ion battery, it's what made the EV revolution possible in the first place, but it also has some really deep-seated flaws.
Yeah, if you're an EV owner or have even thought about becoming one, this list probably looks painfully familiar. You've got that constant nagging worry about how far you can actually go, the hours you might have to spend sitting at a charging station, not to mention the sheer weight and bulk of the battery packs themselves. And of course, there's the safety issue. It's rare, for sure, but that risk of thermal runaway from the flammable liquid inside is always there in the back of your mind. These are the bottlenecks.
But what if we could just get rid of the one component that causes most of these headaches? Well, that's exactly what everyone is racing to do. And it brings us to the solution on the horizon, the all-solid-state battery, or ASSB for short.
The core idea is actually pretty simple, but it is absolutely revolutionary. See, a normal battery uses this flammable liquid called an electrolyte to move energy back and forth. And ASSB just swaps it out. It replaces that sloshing liquid with a super thin, stable, solid material. It sounds like a tiny change, but believe me, it is a complete and total game changer.
And this just lays out the difference so clearly. Over on the left, you've got your standard battery with its flammable liquid. On the right, solid state, totally non-flammable. But here's the real magic that this slide shows us. Look at that third row. That super robust, solid electrolyte makes it possible to use a pure lithium metal anode. And that is the secret key to unlocking a mind-blowing jump in energy density.
And once you make that one little change, the floodgates just open. We're talking about batteries that can cram way more energy into the same amount of space, which means longer range. They're fundamentally safer. They can be charged up incredibly fast. They last longer, for more cycles, and they're lighter and smaller. You can see why people are calling this the holy grail of battery tech.
And let's put a number on that, because this is where it gets really exciting. Early prototypes are already hitting energy densities over 400 watt-hours per kilogram. Now, to put that in perspective, a lot of the best lithium-ion batteries today are kind of hovering in the 250 to 300 range. So we are talking about a massive, massive leap in performance.
And you should make no mistake about it. This isn't some far-off science experiment cooking in a lab somewhere. Oh no. This is a high-stakes, full-blown, global race. The biggest companies in the world are pouring billions and billions of dollars into this, all fighting to be the first one to crack the code and get it to market.
Just look at this timeline. You can see just how quickly things are heating up. A few years ago, it was all about partnerships and R&D. Now we have actual test vehicles on the road. BMW is already road testing this stuff in their cars, and Toyota, who's been a leader in the patents for years, is targeting commercial production by 2028. The race is well and truly on. And what this has created are these incredibly powerful strategic alliances. All the big players are placing their bets. You have automakers partnering with these specialized tech startups like Solid Power and QuantumScape, trying to merge that massive manufacturing scale with bleeding-edge material science.
And you don't have to just take my word for it. Here's a quote from BMW's Vice President of Battery Cells. He says having their test vehicle on the road shows their technology-open mindset. What that really means is that the commitment from these legacy automakers is serious, it's real, and it's what's pushing this whole industry forward at lightning speed.
Okay, so right about now, you're probably asking the same question I am. If this technology is so incredible, why isn't it in my phone? Why isn't it in my car? Why don't we have these solid-state EVs in our driveways right now? Well, it turns out there's one tiny but ridiculously difficult scientific problem that's standing in the way. So allow me to introduce you to the villain of our story, the lithium dendrite. This little guy right here is the #1 reason that solid-state batteries have been so incredibly challenging to perfect.
So what in the world is a dendrite? Well, think of it like a tiny, sharp metal root or a microscopic spike. When you try to charge the battery really fast, the lithium can start to build up unevenly, and it forms these sharp, branch-like structures that just grow like thorns right through the heart of the battery.
And here's the play-by-play of how they do their dirty work. It starts small. Usually it's some tiny defect. Then, as you charge and discharge the battery over and over, they grow and spread, pushing their way right through that solid electrolyte barrier until they physically touch the other side. And boom. That creates a short circuit and the battery is toast. It's dead. Instantly. Solving this one problem is the key to everything.
But as if dendrites weren't enough of a headache, they're not the only problem. There are a few other massive hurdles to clear. Right now, manufacturing these things is still really expensive and super difficult to do at scale. A lot of the current designs also need to be under high pressure to even work, which adds weight and complexity. And then you have the materials themselves, which can actually crack and degrade as they swell and shrink during charging. Each one of these is a huge engineering puzzle on its own. But let's just imagine for a second that they solve all of this. They figure out the dendrites, they get the cost down, they fix the engineering. The impact would be felt far, far beyond just the cars we drive. In fact, one of the most shocking consequences might have almost nothing to do with batteries at all.
Okay, now this is where the story takes a really fascinating turn. Check this out. Some of the most promising designs, like one that Samsung is working on, uses a special silver carbon layer to stop those dendrites from growing. Now, a conventional EV today might use a few tens of grams of silver in all of its electronics. But one of these new solid-state batteries, it could need up to 1 kilogram of silver.
You can probably see where this is going. If even a small fraction of the world's EVs switch over to this kind of battery, it would create an absolutely massive new source of demand for silver. We're talking about something that could send shockwaves through the entire global commodities market. This isn't just a tech story anymore, it's a huge market story too.
And of course, the applications go way beyond just cars. The incredible energy density and safety of this technology make it perfect for, well, everything. Think next-generation smart rings that last for weeks. Medical implants like pacemakers that are safer and more reliable. Lighter and safer power for satellites and industrial drones. Anywhere you need dense, safe, long-lasting power, solid-state could be the answer.
So, when you look at all the money being poured in, all the brain power, all the biggest companies in the world racing to the finish line, the solid-state revolution really does start to feel inevitable. It's no longer a question of if it's going to happen, but really just a question of when. And when it does arrive, it won't just change our cars. It might just change everything about how we power our modern world.